this patient have a bad varus deformity of the tibia, malunion. It was healed, probably it was treated with a plaster cast, and after that it was not so stable. It's deviated so much, and it's created this kind of big deformity in varus. What we need to know here, that important things to understand where we have a deformity. What we do in the tibia is a little bit simple, because you need to design, to design proximal part of the tibia, and like I said you before, mechanical axis and the anatomical axis of the tibia overlapping. And what we see, we design anatomical axis of proximal tibia, anatomical axis in the distal tibia, and we realign that exactly at this level where we broke the bone, there is a deformity. It means this level of deformity, because if the axis will be here, this level, maybe apparently the fracture was below, but the real deformity and the level of where they crossing anatomical axis of the tibia. But now we studied really good. There is no displacement, it's only angulation and simple deformity with the angulation in varus at the level of the previous fracture here. What we do, we need to program the frame that have the hinges exactly of this level of deformity. With the osteotomy, this hinge permits us to do the correction of the deformity. What we use? We use, like before, we use two systems. Each system composite in two rings, one proximal system and one distal system. And what we do, we start to be more demonstrative. I don't pre-build the frame because it's not so interesting. Pre-build is easy, and frequently we need to destroy it. But we build the frame slowly, with step by step attaching our hinges. Okay. What I do, I put this system, proximal system, perpendicular to the tibia. We put the wire now. Okay. Keep here. Like this. I put one wire. Another wire. And this, maybe we may use olive wire better. No, this is bended. Because like you see, there is a varus deformity. What we need to have here, we need to have a support, because we do like this, like a correction with a two pushing force from the lateral side. And another, it will be from the medial side distally. But in the middle of the fracture, it should be support from the lateral side. And here we put the olive wire. Okay, look into the bone. If you want to do fluoroscopic control, but usually it's easy, understandable without fluoroscopy. Put olive here. Okay. And now what we do, we build the frame, because unfortunately for us, the patient don't have procurvatum, recurvatum. Okay. Keep the frame like this. Here, go a few more. Now we start to attach it. Okay, like I said before, this connection bolt should be anteriorly. Okay, one. Center it like this. Touch it. Okay, so it's a little bit medial. We may shift it a little bit like this. Okay. We look at the lateral view, attach a distal wire. Okay. Okay, here we need maybe need washer, because like I said you before, the wire never should be bended. Should be attached with a washer, spacer. Okay. Perfect. If we don't want to lose the stability and the realignment, for this reason I use the tensioner like this. Okay. Okay, olive wire should be tensioned from the opposite side of the olive, because in this way the olive go near of the bone. Okay. Tension of this. Or maybe better we do it with the cube. Easy. Yes. Okay. And now just like you see, it's a little bit stable, not so much, because 2 wires not enough, but okay, centered, what we do, we put a 1/2 pin here to have a more stable system. I think we may put it here, 1 hole, yeah. It's okay. This with 1/2 pin, it will be medial side, anteromedial to the tibia, like this. Perpendicular. Small bolt. Fixed system. Okay, after that we may stabilize it better later. For now it is enough. And Now, what we do, more important things, interesting things, we create the hinges, because like I said, I want to show you step by step like we build the frame. Not pre-build it, but better if you do it slowly. What I see here now, I should see, if you want, you may do it with a fluoroscopy, because we need to create the hinges exactly at the level of the fracture. Like you see here now, you see I put the one whole post, but it's not enough because it's short. What we need to do, we need to do a little bit higher post, okay? Because it will be at the level of deformity. And what we do here, I want to build the hinges, and I need to build it minimum. It will be in the external, or here, external border of the tibia, like this. I want to build it here, okay? Like you see here. It is exactly what I want, like a level, and it should be in the external border of the cortex. Because if I put it medially here, when I do correction, it will be compressed the lateral part, and should be built here. In the way, when I do correction, this correction will be like a creation of triangular or trapezoid regenerated bone. Okay, I put the hinge here. Another hinge, two whole post male, I put here, symmetrically. Bene, okay. And they should overlap in one to another on the same plane, same length. And after that, I use the rods with the female. Maybe we use this not so long. This 8. Okay, we build again the hinges. You take rod, 2 nuts. Female. We'll touch it this way. Okay, we build this. What we do now, we put it here. Like this. Another one we put posteriorly. Bolt. The same plane. Okay, in this rod, direction of this rod should be parallel to the distal part of the tibia. After that, what we take, we create another system, 2 rings again, distal rings. Now only one problem, that here we have this. We need to do like this, maybe like this. But before doing this, we attach it. Okay, like this. Okay. Okay, 1 second, maybe now we should attach. Okay, we put this system in the same hole here. Like you see, this is the first hole here and first hole here, posteriorly. and we should do them at the same length. Distributed plus minus in the way that you keep the proximal and distal part. Good. And now our frame, as we start building, should repeat it exactly the form of the tibia, the shape of the tibia and the alignment of the tibia. And you realize how big deformity is. Monoplanar, but the big deformity in varus, like you see here now. Okay, but it's not enough again. Okay, in this way you practically touch it one to another. Okay, perfect. Now we see, if you want to see it in a fluoroscopy, we may control it. We see that it's realigned to the distal fragment, and now we use a wire, non-olive wire for now. Simple, smooth wire. Okay. I hope you see it, system. Moment. Okay. What we do now, we see the bone. Okay, and this way I put simple wire perpendicular to the axis to the distal tibia, like this. Okay, to bolt. One fix it here. Another here. Okay. If this road's not comfortable, we may change position. Okay. I tied this. Good. No. Tension from this side immediately. No. Oh, this. Okay, now you see, I tight it. And the frame now in lateral view is realigned perfectly. Like we said, that this is only one plane deformity on varus, no procuratum. Procuratum, for this reason, we don't need to buy planar hinges, but this hinge is only monoplanar, and we correct the varus deformity. Now, we put olive wire here, because like I said you before, we need two pushing force from the lateral side. This is one olive here. Now we put another one here. Pay attention. Okay, we put this. Maybe displace it in different, huh? Okay, I've fixed this half with this wire. Okay, I tied this. Pay attention. Okay, tight. And now I should tight a little bit more to be sure that it's good done. Okay, perfect. I cut this because it's dangerous. These tips, better cut them always in workshop. Okay, we bend this wire. Now 4 wires, just maintain the good realignment. We bend them. Okay, here, if you want, we may break it. Okay, different way of treating the wires. Okay. Now you see 2 olive wires from medial, and the way when we corrected, this olive touching the bone, and they produce the pushing forces to correct the deformity. After that, what we do, we should reinforce all this system. We put another half pin here, for example. Yeah. Maybe this small one, yes, it's okay. Half pin here. Sure. Okay. Distal tibia. Oh, we don't have fibula, but you need to fix fibula, obviously. With the wires like I explained it before. In this case of malunion, the patient should be comfortable enough for this reason, like I explained in the beginning when we talked about the fracture, that that we need to fix the fibula with the we will fix the fibula with a big Kirchner wire, 2.5 or 3 millimeter Kirchner wire. They go to the fibula and the tibia from the lateral side, but it's remaining under the skin, only at the level of the cortex of the fibula. Okay, now we fix this. It's just much more stable. Obviously, we may stabilize it much more, the frame. If you want to continue, we may put another half pin, another wire here, proximally. We may put another wire distally. If you are not sure about these two wires, we may put a half pin here, but we don't need to do now stabilization because what we need to know now, how we position the hinge. We find this. This is a hinge for correction. And what we should do, we should create the motor for this correction because this is more important things to do, to create the motor for the correction. Well, how we do this? Probably we have some kind of motor. We may do this, or if you want, we may use this one, for example. Because here we can put the normal rods because there's too big deformity that it will be difficult to put the rods because the distance here is small, and we prefer to do the motors, long one maybe. Oh, we may put this for correction of the deformity. How we put this, or in vice versa, we will put like this. This motor should be put in the middle. Okay. Do you have this? Yeah. Yes. Okay. This is there is a different system for creating the motor. Maybe if you had time, I show you. One of this is automatic, I may say, because it is much more easy for the patient to use this one. Okay. I put this because it's going inside. No, I put the wrong one. I put a little bit longer. This is comfortable system because it's you may turn it continuously in the without using the wrenches. After that, it depends of you. It is a little bit of your fantasy. Here, what I may do here, for example, I put like this here. Or where I can put it. Yeah. Okay, like this. Yes, here I may put one, for example, 2-hole female post. Okay, like this. We have only one, like a plane of deformity. We don't need to put biplanar hinges. Okay. One spacer maybe here. Yes. Like this. Okay. And this is some kind of hinge. Why we create this system? Because this system permits to do progressive correction, and we have in this system two hinges, one distal, one proximal, here and here. In this way it is adapted really easy. I only afraid that this will touch here, and for this reason I should put the hinges differently, because we do the correction and after that the rod touch it. Better that we displace it again like this, lateralize it in this way. We put this post, okay. And then we put again this bolt. And no, it is but a little bit longer.
Okay.
Yes. Like this. And this is our motor. Comfortable for the patient. Tight here. This the patient uses, but we start to use it after with osteotomy. This is one system for correction. Another system that, if you want it, we do it only for explanation. What we may do? We may do this inside of the system. Maybe we have two hole posts again, female or male. No. Oh, we'll find it somewhere because we put somewhere. Yeah. It was here. Let's see. It's only for showing you. See, I show you now this in the video. Oh, yeah. What we may do here, we use this two hole post. We may put it here, for example, but like you see, we have a really few space here. Okay. Because it's if I mount in this system, for me it's really difficult to mount, because you see this is in the second hole. Now I should put this one the same in the second hole, but it's so near that I have a big difficulty to put inside. You see, I can't go inside, and for me it's create big problem to mount it, okay? But I show you oppositely these difficulties. Okay, it goes with difficulties. Okay. I did this, I attach it, but in any case, you see there's so few space that I can't put it comfortable inside. You see? And this created a little bit of displacement because the roads is not parallel. But this happened because of the big amount of deformity. For this reason, the hinge like this much more comfortable. But we leave it this for show you in any case how it will be function. later because its principle of this system remained. Another system we may use is system, and from the lateral part we take another one, two-hole post. It was in another frame again. Okay. Remove this. Because the hinges should be in any case in the same level. For this reason we're looking for two-hole post and we use it for correction. Okay. I put it in the middle, this one here, but it will be no more medial but lateral. In biomechanically, this hinges is not so how to say it, not adaptable here because we need to do more force which should create on the medial side for correction of varus. If we do correction from the lateral side, it is the space, the medial side, there is no power. And I show you later when we start to doing correction. But only for understanding, I show you this system again. It's a little bit short. Put another one with female.
Female, 3 holes?
No, one hole.
One?
It's only for the more length. Okay. No, small one. Too short. Okay. Give me range. Thank you. Okay. Okay. I put it medially. Only to show you. We should respect the symmetrical position of the holes. And again, I should notice you see, if I put this rod like this, geometrically calculated what's happened here. That this rod is not perpendicular to the ring here. And like you see, it is a little bit inclined because if the two rods have this big inclination, the distance between this two system and these two rods is different because the inclination of the rings. For this reason, that the much more comfortable, much more much more powerful system, this motor here, it is not so comfortable for the patient because it's bulky, but it's comfortable for turning the nuts, but much more important that this motor will be function better of all other system here. Okay, but now what I show you, I should show you how it is function. We remove the plate. And one. And two. We have the screw that fixes the fracture, interfragmental screw. Remove this. Okay. And now our osteotomy is free. Like I said you, before doing osteotomy, we disconnect the frame. We maintain the same position. Now we may tighten it a little bit, this posterior anterior rod. We release a little bit the hinges. all of them here. What I do, I release here because now I can't put in the inside because it's so near, but I keep it ready when it will be possible. We put the bolt here. And see how it's different, big difference, because this inclination, they are so near that I can't overlap in the holes here, because its position of this hinge is not comfortable. Okay, what we do now? Now we do correction. I release this rod, because this rod should go in a shortening. And what we do slow correction here. We rotate, we lengthen it, okay? Like you see what's happened, there these rods became more and more parallel. Okay, we go. It looks slowly, but in real life it's fast. Maybe in 3-4 weeks we may do all this correction. Like you see here, my external rod now shorten, it will function the same. If I do the same correction here, it will be functional, but only the problem that's here there is no power. But it's possible to do with this system, compression of the lateral rod function. Now you see my rod that was not uncomfortable became working now, function. I put now here the bolt because it is my hinge here. If the deformity will be like this in the beginning, not so much deformity, it is possible to do this kind of system. You see, maybe a little bit more distanced because in this way distributed better. One here, one posterior, and this motor functional. With this big inclination, it was not so easy to boot it. For this reason, we use a motor because of big deformity. And what we do here, we do distraction. You see, it is the same function. I do now here correction, and simultaneously I do motor. But if I don't use motor, I might do only with this system, like this. You see, it is going good. Lengthen, okay. Everything going functionally, okay. And look at the bone. You see now the bone start open more and more. And like I explained you, my hinges, it is touching the external border of the bone, just a little bit external, like you see here. And this permits me to do lengthening. And just a little bit lengthening in the lateral side and much more lengthening in the medial side. And continue. Okay, my lateral rod short, this lengthening. I do correction progressively, more and more and more. Motor function. You see, it's quite parallel. This is lengthening again. And now you see this is perfect realignment of this motor. We do more and more. This rod quite finished. Okay, like you see now, this motor functioned, it became parallel because the rings are parallel, they are a symmetrical system, symmetrical rod here and here and here. And practically we are finished. And this motor was really helpful because more powerful and situated medially. When we finish this lengthening, you see, the bone is exactly straight. We create regenerated bone, trapezoidal shape bone, because here we did it just a little bit lengthening, maybe 3 or 4 millimeters, much more lengthening, more than 10 centimeters in the medial side. In this way we correct varus. If you need more lengthening, this lengthening may be produced by lengthening of these two rods simultaneously or in the beginning. If you don't need lengthening, only correction, you do like this. And if you want to do shorten at the end, you may do shortening of this rod in the way that your fracture or your osteotomy will be completely realigned, and the bone touch it one to another. Like this. Compress. Okay, now it's perfect correction. No lengthening, only correction of deformity. Okay? If you, this is the lateral view, but maybe it is inclined a little bit. Okay, and now we correct completely this varus deformity. There is no rotation, no other deformity. Maybe I put it just a little bit like this, because it's system a little bit external rotated. Now better, but not easy. I don't know if you see the same like this. Now it's completely corrected. Remove this. Okay. If you want, we are not so many people, come here, we see together in a live how it is functioned. If you want to touch it, if you want to rotate it, and this is now, you see, completely straight with a good regenerated bone inside. Okay? Your questions, please. What you understand or what something you don't understand, and how. Microphone, maybe somebody wants to ask me something.